Today we will continue with the topic of quadratic equations, but we will start to see the specific methods for solving the quadratic equations. The first method that we are going to see is the factoring method. So first of all, remember that a quadratic equation is normally a trinomial. It can be ax squared plus bx plus c equals 0 or x squared plus bx plus c equals 0. These two, both of them are cases of factoring, so that's why many of the times it will be possible to solve the quadratic equations by factoring. Not all of them. That's why it says because of this it's possible to solve many, not all, because not all trinomials are factorizable. We can solve many of the second degree equations by factoring. And of course, also, the steps for solving it is going to be very simple. It says transform to have the normal structure of a trinomial, factorize the trinomial, equalize both parentheses to 0, and isolate the x. That will be the process for solving it. But remember that sometimes they will ask you to do the verification process. If they ask you to do the verification process, it says we need to do the verification process in the original equation as always, not on a middle term equation or something like that. We need to make it on the original one. So let's see some examples of how to solve quadratic equations by factoring. So the first of all we have here, first we need like to eliminate the parentheses and so and all of it to have the structure of a trinomial. So it's going to be 1 minus 3x plus a binomial squared is going to be the first one squared minus 2 times the first one multiplied by the second one plus the second one squared. This minus 5 will multiply this and this, so it's going to be minus 5x plus 10 equals 11 minus 8x. Then we need to change all the terms to the same side. So we will start with the x squared. It's going to be 9x squared. What about the x? It's minus 3, minus 6, it's minus 9, minus 5, it's minus 14. This minus 8 will become a plus 8, so it's going to be minus 14 plus 8, it's going to be minus 6x. Then the numbers is going to be 1 and 10, it's 11, minus 11, it's 0, and the 1 that we have here, so it's going to be plus 1 equals 0. So we have now the structure of a trinomial. This is a trinomial, so we need to factorize it. Remember, for trinomials, we have three possibilities. We have the ax squared plus bx plus c trinomial. We have the x squared plus bx plus c trinomial. And we have also the perfect square trinomial. So this one that we have here, it's a perfect square trinomial. Why? The first one has a square root that it's 3x. The third one has a square root that it's 1. And the middle one will be 2 times the first one multiplied by the second one. That means we can factorize this one as 3x minus 1, all of it squared, equals to 0. So it's going to be 3x minus 1 equals to 0. The squared one, we can move them to the other side as a square root. Or we can put two of them. In this case, we can put it also as 3x minus 1, 3x minus 1 equals to 0. And we can equalize both parentheses to 0, but in this case it's going to be the same parentheses, so we will have only one value for x, and it's going to be 3x equals 1, x equals 1/3. So we have solved the equation. In this case, we have only one value for x, not two of them, because the two values of x are exactly the same. What does that mean with that answer? Remember, the value of x is where it crosses the x axis. So in this case, it's in 1/3. So it's going to be something like here. It will cross there. And remember, the C term is where it crosses the y-axis. So we can know that it will have a form like this. It will only touch specifically on this point, and it will cross the y-axis exactly on 1. Why? Because remember, the C is where it crosses the y-axis. The value of x, we haven't seen it because we haven't like solved the actual roots, but now we are solving it, is where it crosses the x-axis. In this case specifically, it has only one solution because it only touches the x in specifically 1/3. Now, I will do the verification process only for example number 1, but if they ask us to do the specific verification process, what do we need to do? So let's see. So if x has a value of 1/3, we need to put it in the original equation, and it's going to be 1 minus 3 that multiplies 1/3 plus 3 that multiplies 1/3 minus 1 all of it squared minus 5 that multiplies 1/3 minus 2 equals 11 minus 8 that multiplies 1/3. So let's see. It's going to be 1 minus 1 plus, here it's going to be 1 minus 1 all of it squared minus 5 that multiplies, here it's going to be 1/3 minus 6/3 equals 11 minus 8/3. So of course here it's going to be 0 plus 0 squared, that it will be 0 minus 5 that multiplies, and it's going to be minus 5/3 equals, and here it's going to be 11, we can change it to thirds, and it's going to be 33/3 minus 8/3. So this one gets eliminated, so it's going to be 25/3 equals 33/3 minus 8/3. 25/3 equals 25/3. So we have finished the verification process, and it's correct, the answer of x. Of course, what happens if we have two values of x? We need to check both values to see if they are possible roots of this specific equation. So remember, the verification process must be done in the original equation. In this case, I only did it one time because the value of x is only one value. But of course, if we have two different values of x, we will need to do the verification process twice. So let's go to the second example. So let's see the second example. In this second example, we have something like this. Of course, the first thing we need to do is we need to eliminate the parentheses, and so on the first parenthesis, depending if you remember about the special products, it will be very easy. If not, you will need to multiply everything by everything, and at the end you will see that many of the stuff will eliminate. Why? This thing that we have here, it's an special product that it's called a binomial but a trinomial. Why? Because it has this structure. I will put it here. We have a minus b multiplying a squared plus ab plus b squared. If we remember that special product, it gives us a difference of cubes. So in this case, it's going to be the first one cubed minus the second one cubed. Then we can continue with this part, and it's going to be minus 2x multiplying this multiplying this, so it's going to be plus 2x squared equals 27x cubed minus 343. What happens next? Of course, it's going to be 27x cubed minus 343 minus 2x plus 2x squared. We can change the orders from side and we can put them here. Minus 27x cubed plus 343 equals to 0. What happens? This one with this one, this one with this one. So we have 2x squared minus 2x equals 0. How can we solve this one? We can take, or we can use the factoring case. In this case, which case of factoring can we use? We can use, or we can take out a common factor, greatest common factor. So we can take out a 2x to become 2x squared multiplied by x, 2x to become minus 2x multiplied by minus 1 equals to 0. So in this case, we can equalize both to 0. So in this case, x equals 0 over 2. That means x equals exactly to 0. 0 divided by everything, it's 0. And the other one is going to be x equals exactly to 1. So we have that the values of x are going to be 0 and 1. What does that mean? Remember, the values of x will tell us specifically where, here on 0, here on 1, are going to be specifically the parts where it will cross. And in this case, because we don't have a specific value of c, because a has a value of 2, b has a value of 2, and c has a value of 0 because we don't have an independent term, that will mean it will cross here the y-axis. So if we see this specific one, it's going to be something like this. And it will cross here, and it will cross here. Remember, the x will tell us specifically where it crosses the x-axis. The c value will tell us specifically where it will cross the y-axis. So let's see another example. So the third example is going to be something like this. So in this case, to have the structure of a trinomial, first of all, we need to eliminate the fractions. How do we do it? We need to multiply all the equation by the least common multiple. So in this case, we need to multiply all the equation by the least common multiple, that it's 4x. So what will happen? Of course, the first one, x, will multiply by 2x because it's the part that it's missing on the denominator. The second one will multiply by 4 because it's the part that it's missing. And the third one will multiply by x, that it's the part that it's missing. So it's going to be 2x squared minus 20 equals x squared minus x. If we put them on the single side or in the same side of the equation, it's going to be 2x squared minus x squared plus x minus 20 equals to 0. That means going to be x squared plus x minus 20 equals to 0. So in this case, we can factorize it. And let's try to factorize it. We have an x squared plus bx plus c trinomial. So remember, in this case, we will put the sign of this one here. Plus, to become minus, we need a minus. Two numbers that when they get added, it's plus 1. When multiplied, it's minus 20. 5 and minus 4. When we multiply 5 times minus 4, it's minus 20. When we add them, it's plus 1. So we can put x plus 5 equals 0. We can equalize them to 0. X minus 4 equals to 0. X equals minus 5. And also x equals plus 4. Those are the answers for the specific equation. What does that mean? Remember, it will cross specifically here, x equals minus 5, x equals 4, and we know also, because the value of c it's minus 20, that it will cross the y-axis on minus 20, that it will be maybe here. So it will have, sorry for the bad graph, it's going to be something like this. And that will be the form of this specific equation. So that will be the information that we can know about this exercise number 3. And specifically for this exercise number 3, I will also do the verification process. So let's see the verification process for exercise 3. So let's start to do the verification process. Remember, the verification process must be done on the original equation. So we have minus 5 halves minus 5 over minus 5 equals minus 5 minus 1, all of it divided by 4. So let's see, here it's going to be minus 5 halves. Here it should change to plus because this minus goes here. 5 divided by 5 it's 1, so it's going to be minus 5 halves plus 2 halves, and it's going to be minus 3 halves. Let's see the other side. It's going to be minus 6 quarters. It's divisible by 2, minus 3 halves, minus 3 halves. So yes, this is a correct answer for the x. X can have a value of minus 5, so let's see the value of 4. So when we have the value of 4, we need to again check the verification process on the original equation. So it's going to be 4 over 2 minus 5 over 4 equals 4 minus 1 over 4. So it's going to be, we need to change it to fourths. So here it will stay the same. Here it's going to be multiplied by 2, so it's going to be multiplied by 2 also, equals 3 quarters. So it's going to be 8 minus 5, it's 3, so it's going to be 3 quarters equals 3 quarters. So we can check that the left side equals the right side. So in this case, the second one it's also correct. And that way we will be able to verify the answer of the quadratic equation. Remember, if we have one answer, of course, we will do the verification process once. If we have two answers, we will do the verification process twice on the original equation, always on the original equation. So let's see another example. So imagine we have something like this. So it's going to be 20x squared minus 20x. We can change the other ones from side. 20x minus 500 equals to 0. This one and this one eliminate, so it's going to be 20x squared minus 500 equals to 0. Remember, in this case, we need to use factoring. If we take out the 20, it's going to be x squared minus 25 equals to 0. We can factorize again. It's going to be 20 that multiplies x plus 5, x minus 5 equals to 0. Of course, we can equalize everything to 0. Of course, this one, it's not an answer. 20, it doesn't equals to 0, doesn't matter, because we can change it to the other side dividing. Say 0 divided by 20 is 0. That's why it's not an answer. In this case, x equals to minus 5. The other one, x equals to plus 5. That will be my answer. What do we know on this specific exercise? We know that it will cross exactly in minus 5, exactly in 5, the x-axis. The y-axis, of course, here a has a value of 20 b has a value of 0, and c, that it's the independent term, equals to minus 500. Of course, my little graphic will go here to minus 16, but if we can go down, it will go to minus 500. Exactly on minus 500 is specifically the point where it will cross the y-axis. And of course, if you want to check or verify these two answers, what can we do? We can put them on the actual original equation, and we will check out if the left part equals the right part in order to see if our answers are correct. So let's see one last example of how to solve quadratic equations by factoring. Imagine we have this equation. So what do we need to do on this one? We need to multiply by the least common multiple in order to eliminate the fractions and have a whole number equation. So it's going to be 10x. So the first one we are missing 2 and x. On the second one we are missing a 10. And on the third one we are missing the x. So it's going to be 2x squared minus 20 equals 3x. If we put them in the same side of the equation, or we pass everything to the first member, 2x squared minus 3x minus 20 equals to 0. So we have an ax squared plus bx plus c trinomial. So remember a little bit, we need to multiply the corners, minus 40x squared. So in this case, we write the corners. The middle one, we will decompose it into minus x, minus to become minus, we need to multiply it by plus x. And we need two numbers that when they get added, it's minus 3. When multiplied, minus 40, 8 and 5. Because minus 8 times plus 5, it's minus 40. Minus 8 plus 5, it's minus 3. These two of them have something in common, that it's 2x that multiplies x minus 4. Plus these two have 5 in common, x minus 4 equals to 0. So it's going to be x minus 4 multiplying 2x plus 5 equals to 0. So we can equalize both to 0. X minus 4 equals to 0. 2x plus 5 equals to 0. X equals to 4. So we have the first value of x. 2x equals to minus 5. X equals to minus 5 halves. That will be another answer. What does that mean? Remember, it will cross the x-axis here when x has the value of 4. Minus 5 halves is going to be minus 2.5. So it's going to be exactly here also. So it crosses here. And in this case, the value of c, it's minus 20. So the value of c will tell us specifically where it crosses the y-axis. So it will have this specific, this specific form. Maybe. So remember, if we want to do the verification process, we need to verify both of our answers on the original equation. Of course, I won't do it on the video because of the time issues. But remember, the process is always the same. First, we need to transform an equation to have the trinomial form maybe. Then we need to factorize the trinomial. And then we will need to equalize both parentheses to 0 and isolate the x. And only if they ask you to do the verification process at the end. So that will be it for today's video. That it was how to solve quadratic equations by factoring. Remember, not all of the equations are possible to solve by factoring. See you on the next video.